In this video, we're going to talk about weight and mass and how they're directly related and how they're different. Mass is the amount of matter an object is. It is unchanging or constant regardless of location. So if it's 110 kilograms on Earth, then it's 110 kilograms on the Moon or Saturn. That does not change. Weight is the amount of force pulled down by gravity in a certain location. So this does change, or it varies by location. So we can calculate weight from our mass depending on our acceleration due to gravity. All right, so some example problems. What is the weight of an object that has a mass of 75 kilograms in English units? So the mass is given to you. They want to know the weight. If there's something mentioned about the location, you can assume that it is Earth. So because of that, we're going to use the conversion. 1 pound is equal to 0.454 kilograms. And this is only because we're assuming it's on Earth. So converting that using our fences method. When you convert that, you get 165.2 pounds. And we know to put it in pounds because we were talking about the English unit. Number 2, what is the weight of an object that has a mass of 40 kilograms, and they want it in metric units now. So here we're going to use the weight formula. M stands for mass, G is the acceleration due to gravity, and W is the weight. That's what we're looking for in metric. So we're going to use 40 for our kilograms. The gravity acceleration due to gravity on Earth is 9.8 meters per second squared. And you get 392. And whenever you're using this equation with these two units, kilograms and meters per second squared, your weight will be in newtons, the metric unit. So 392 newtons for the object. Number 6. What is the mass of an object that weighs 4 tons? So 4 tons can be converted into pounds. And we care about converting it into pounds because we want to find out the mass. No mention of location, so we're assuming that it's on Earth, so we can convert that. So tons, there are 2,000 pounds in 1 ton. And then from pounds to kilograms, we already mentioned the conversion, but I'll show you again. We have every 1 pound is 0.454 kilograms. So when you multiply 4 times 2,000 times 0.454, you get 3,632 kilograms. Number 7, what is the mass of an object that weighs 1,500 newtons? Again, no mention of location, so we're going to assume that it is Earth. So in this equation, newtons, 1,500 newtons is the weight. What is the mass? We don't know. Gravity, we're assuming is Earth's. So 1,500 equals m times 9.8. So we're going to solve for m here. So whatever m ends up being, going to be in the kilograms units. So you're going to divide both sides by 9.8. Should be roughly 150. So 153.06 kilograms. So just go through and define your variables, what you are given to you, and then what you're being asked to find. Let's look at a problem like number 8. What would the weight of a 95 kilogram person be on Mars? They want the metric and then the English. For the metric, we're going to be using the weight formula. Weight equals mass times gravity, or acceleration due to gravity. The mass we know. Now on Mars, we know from our table, Mars right here, 0.38 in terms of relative to Earth's gravity. So you're going to take Earth's gravity, 9.8, and you're going to multiply it by 0.38. That gets you that 38% of the gravity. So your weight on Mars would be 353.78 newtons. Now what are they going to be in English units? You're going to take that and convert it to pounds. And on your green sheet, there is a unit conversion. So from newtons to pounds. Every 4.45 newtons is 1 pound. So you're going to multiply and then divide, and when you do that, you get 79.5 pounds. All right, number 9. If someone can lift 175 pounds on Earth, how much could they lift on? And they give you a bunch of different options here. And they want the English units because they give it to you in English. The moon, for example. If the moon, which has about 16%, right there, 0.16 of Earth's gravity, you should expect to lift more than that, 175 pounds. So what you're going to do is instead of multiplying 175 times 0.16, you're going to do 175 divided by 0.16. And when you do that, you get 1,093.75 pounds. You should be able to expect to lift almost 1,100 pounds if you can do 175 here. If you were to multiply these two numbers instead of divide, you would get a number smaller than 175, which wouldn't make a whole lot of sense if Moon's gravity is less than Earth. Let's try Mercury, for example. Mercury, 175. We're going to divide it by the relative gravity of Mercury. It's 0.38. Again, you should be able to expect, or you should be able to lift more on Mercury because we have 38% of the Earth's gravity. 460.5 pounds. So that's more than 175. Certainly not as much as the moon, because the moon has a far less gravity than even Mercury does. Number 10, how much does a 74 kilogram person weigh at, and they want this in English units, near the equator, Denver, Greenland? If they give you specific places, you're going to be using this table here with the specific field strengths. All right? If it doesn't say a specific place, you're simply just going to assume it's Earth's gravity, 9.8. But near the equator is going to be a latitude that's close to 0. So 6 degrees south or 9 degrees north, those are pretty close. They end up being the exact same. So we're going to use 782. So weight's going to be 74, 9.782. And you're going to get 723.89 newtons. Now at this point, you are finding the weight, but they do ask for it in English units, so you're going to have to convert that to English units. So 723.89 newtons. Make your fence 1 pound. And when you calculate that, you get approximately 162.67 pounds. You can always convert it after the fact if you're looking for the English units. All right, last question. What would the mass be of an object on the moon, Jupiter, and Earth if the mass of the object currently is 80 kilograms? In the beginning of the video, we talked about mass being unchanging or does not vary based on location. It's always constant. So if it's 80 kilograms somewhere and they ask for the mass on the moon, then it's going to be the same exact mass. On the moon, on Jupiter, on Earth. Mass does not change. So if the question gives you a mass and then asks for a mass, you're going to simply repeat the mass because you know that the mass does not change.